In the last video, we determined how to tell whether or not a graph is a function or not, and that's by looking at the input line and seeing if there's more than one output for every input. And a really quick, easy way to figure that out, rather than going through and looking at each x value and each input, is do what's called the vertical line test. And so what you're going to do is you're going to take a vertical line. You could use your finger, you could use a pencil, you could just imagine a vertical line passing along your graph. And the way that the vertical line test works is that you are going to look to see if your vertical line passes through the graph just once as you move it across the x-axis. And so, for example, this first graph, as you see, I'm dragging this line, and you can kind of follow where it's crossing my vertical line, and there's no point that I can drag this vertical line, oops, drag the wrong thing there. There's no point, at no point when I drag this vertical line do I cross through this vertical line more than once. Now, contrast that with my second graph here. If I were to drag my vertical line across, you can see quite immediately I have two intersections with this line. So if you have more than one intersection at any point with the vertical line test, you do not have a function. So that's a really quick and easy way to spot whether or not you're dealing with a function or not. Okay, on to the next page here. I'm going to give you an opportunity to do some practice on your own here. And what I want you to do is, given the following ordered pairs, I want you to represent the relation using a table, a graph, and a map. So here we have a table, here we have a graph, here we have a map. I want you to take these ordered pairs and put them in the proper format here. So what I'll do is I want you to pause the video, and I'm going to go through the examples, and what I'll do is I'll leave a little link somewhere on the video so that you can jump ahead to the answers. And if you want to see how any specific one of these is done, you are welcome to go back and see how I did it here. So why don't you pause and go ahead, and I'll go ahead without you. Okay, for letter A here, for our table, we're going to set up our X, Y columns. We've got our input, we've got our output, our domain, our range, our X and our Y. So let's take our X's. I've got a 0, we've got a 2, and I've got a 4. And let's take our, looks like that's it for the X's. So let's take our Y's. Oh, no, I made a mistake here. I want to put down in my table, I need to put down all of the inputs. So I've got a 0, a 2, and I'm going to actually include the other 2. And then I have a 4, and then a 4, and one more 4. So actually I misspoke before, with a table, you should reflect all of your pairings. With 0, I match a -1. With 2, I match a -1. Next, I have a 3. Next, I have a -1. Then I have a 2. Then I have a 4. So there's my table set up. All of the pairings are represented here by each row. All right, now let's take a look at the graph. That'll be, let's see, I'm going to do the graph in red. So let's graph all these points. I've got 0, -1. I've got 2, -1. I've got 2, +3. 4, 1, 2, 3, 4, -1. 4, 2, and 4, 4. There's my graphical representation of this relation. And then finally, let's move on to number 3 here, the map. So the map, I'm going to have my X over here, my Y over here. This is my domain, this is my range, this is also my input, this is my output. And let's put all of my unique inputs. So I have a 0, I have a 2, and I have a 4. Those are the only inputs that I have. They repeat, but each individual input is given by 0, 2, and 4. So as far as my outputs, it looks like I have a -1. I've got a 3. Got some -1s that repeat, so I'm not going to repeat that there. Then I have a 2, and I have a 4. So those are all of my outputs. So now let's actually do the mapping part where we're going to draw my arrows that point out how each input maps to an output. So let's see, 0 maps to 1, 2 maps to -1, 2 also maps to 3, 4 maps to -1, 4 maps to 2, and 4 maps to 4. So we got a lot of crossed wires over here. So let's decide whether or not this each of these or if this one relation represents a function or not. So no matter what, this is a relation since we're relating an input to an output. So what do you think? Do you think this thing's a function or a relation? Take some time to think about it, and we'll see here. All right, in determining if this thing's a function or not, we need to look at the inputs and the outputs. And for our inputs, we have 0, 2, and 4. Our outputs, we've got -1, 3, 2, and 4. And we could see here that our inputs can point to more than one output. So you could see that with the table, we've got a repeated input here going to different outputs. We've got a vertical line test is failing if I were to hold a vertical line over these points. And then also for my map, I have multiple arrows coming out of the same input. So this is not a function. Oops, not a function. So what I'd like you to try on your own then here is I've got a whole bunch of examples for determining if the following maps are functions. Remember, you're trying to count how many outputs are produced for any one input. Every single input should have just one output if it is a function. So why don't we first start off with A, B, and C. Go ahead and pause the video, and then I'll leave a little link for you to jump ahead to see if you're right. All right, for letter A here, we're taking a look at the inputs, and each of my inputs has only one arrow coming out of them. So that means that every input has just one output. So that passes our test. This thing is a function. It's okay to repeat our outputs. It is not okay to repeat inputs. So make note of that. Let's see, for letter B next, for our domain, we've got 15, 18, and 0. In our range, we have all these points. So the mappings are a little bit different, but they're still mappings as they're pairs of information. And when I go down my line here, I've got one arrow coming out of this 15. I've got 2 arrows coming out of 18, and that already breaks down. Since I have a repeated input mapping to 2 different things, this is not a function. And then finally, C here, I've got a mapping of 1/3 to 0.3 repeating, 1/5 to 0.2, 1/11 to 0.09 repeating, and then 1/4 to 0.25. Every single input has only one output. This one here is a function. All right, so here are the answers for this one. Feel free to jump back if you want any explanations for either of these. And next, if you're feeling pretty good about this, why don't you try D, E, and F? These aren't traditional maps. They're not all numbers. We have some letters and some words, but the rules still apply. So give these a shot. All right, for A, or rather for D here, each of my inputs has just one output. So I've got one line coming out of math, one line out of physics, one out of foreign language, one out of English. So since there's only one output per input, this is a function. And for letter E here, same thing. I've got one arrow coming out of A, one arrow coming out of B, one out of C, one out of D. This is a function. And finally, for letter D, or rather letter F, we'll see here that water has 2 arrows coming out of it, salt has 2, methane has 2, sucrose has 2, and because there are multiple arrows coming out of the same input, this is not a function. And here are your